All right, ladies and gentlemen, in this video, video number 3, we're going to be talking about something called empirical formulas, defining them, what are they? Likewise, molecular formulas, what are they? And how we can do some of the math of chemistry with these things called empirical formulas. So you need your notes up into where it says video number 3. So an empirical formula. Empirical actually means determined through like testing experimentally, and there's lab equipment out there that by analyzing a compound, it can actually determine the lowest whole number ratio of the atoms in a compound. So basically, an empirical formula is a formula where all the subscripts have been reduced down as low as they can get and still be whole numbers. The empirical formula is essentially your reduced down formula. Now, what I mean by that is if you take the compound C6H6 right here, this is not the empirical formula because the subscripts, 6 and 6, they have a common multiple. They can be reduced down further. So that's not an empirical formula. But if you take the 6 and the 6 and you reduce them down to basically to 1 and 1, you get the empirical formula, which is CH. So glucose, C6H12O6, this is not an empirical formula because the subscripts aren't as reduced down as they can get because they're 6, 12, and 6. If you do reduce them down as far as you can get, then you have an empirical formula of CH2O. You're basically looking for a common multiple between all the subscripts and reducing it down as far as possible. Now, water has subscripts of 2 and 1. So water has an empirical formula that's actually the same formula, 2 to 1, because you can't reduce 2 and 1 down further and have them still be whole numbers. So you can absolutely have a compound like water where the real formula, which is the molecular formula, is the same as the empirical formula. So molecular formula is the true formula, the actual formula of a substance. That means it's the unreduced down version. The before you take the subscripts and reduce them all the way down, we call that the molecular formula. So as an example, dinitrogen tetroxide, N2O4, this is a true formula, a molecular formula, because notice how the subscripts, they're not reduced. 2 and 4 have a common multiple. So this is a molecular formula. It is not an empirical formula. The empirical formula of N2O4 would be NO2, reducing the subscripts down. Water, on the other hand, H2O, this is a molecular formula because it's the real formula for water. Right? Water's not anything else, but it's also an empirical formula because the subscripts are already as reduced down or as they can get. So you can have a compound that is a molecular formula, but it's not an empirical formula. You can also have a compound that is a molecular formula. It's the real one, but it is also the same thing as the empirical formula. So determining an empirical formula from a molecular formula. So basically this is, I give you the molecular formula and I ask what is the empirical formula. You are looking for a common multiple. You want to find the largest common multiple between all the subscripts in the formula. And then simply divide each of the subscripts by that common multiple to create the empirical formula. So for example, C6H9O3, if we look at the subscripts 6, 9, and 3, there is only one, there's the largest common multiple between these three values, 6, 9, and 3, is 3, largest common multiple. And if you divide all of the subscripts in C6H9O3, if you divide 6 by 3, you get 2. If you divide 9 by 3, you get 3. And if you divide 3 by 3, you get 1. Remember, invisible ones in chemistry. And then we have the empirical formula for that molecular formula. On just another example, C2H14, the subscripts 2 and 14, their largest common multiple is 2. Right, not 7. You divide each of these subscripts by 2. 2 divided by 2 is 1, and 14 divided by 2 is 7, and then we get the empirical formula for this particular molecular formula. So just as an example, are the following compounds empirical formulas if not determine the empirical formula? Well, N2O5. Between the subscripts 2 and 5, there is no common multiple where we still get a whole number. So this is an empirical formula. It cannot be reduced down any further. So that's an empirical formula. Versus the formula C2H6. Well, now we do have a common multiple between 2 and 6. The greatest common multiple is 3, right? So this is not an empirical formula, but if we divide, the greatest common multiple is 2. If we divide each of these by the greatest common multiple, which is 2, then we get CH3. C6H12O6, this is not an empirical formula, because between 6, 12, and 6, we have a common multiple of 6. So if we divide all of the subscripts by 6, we get the empirical formula of CH2O. So C6H12O6, not an empirical formula, not a reduced down version. But if we look at so C6H12O6 is glucose, and the next one is sucrose, C12H22O11. With these subscripts 12, 22, and 11, there is no common multiple. Basically because of the 12 and the 11, right? There's no common multiple between 12 and 11. So this actually is an empirical formula because you cannot reduce it down any further. Now going in the other direction is a little bit tricky, meaning I give you an empirical formula and I say, hey, what's the molecular formula? This involves a couple additional steps, and they're not hard. But the key is it's trickier because we don't know the common multiple and we have to figure it out. So if we, for example, if you have an empirical formula of CH2, the ratio between the carbon and the hydrogen here is 1 to 2, C to H. So you could have any number of possible molecular formulas, lots of different molecular formulas. All of these compounds, CH2, C2H4, C3H6, C4H8, they all have a 1 to 2 carbon to hydrogen ratio. So these are all possible molecular formulas, and we don't know which one it is. So the key is determining what is the common multiple. So if you have a problem like this, where you need to go from the empirical formula to the molecular formula, then the first step, big point, you're going to be given the empirical formula, find the GFM of the empirical formula. Find that gram formula mass, calculate it. And then you're going to also be given the gram formula mass of the true thing, the molecular formula. You want to divide the molecular mass, the gram formula mass of the molecular formula by the gram formula mass of the empirical formula. What you're doing is figuring out the common multiple. This work right here, dividing the mass of the real thing by the mass of the reduced down thing, you are figuring out how many times larger the real thing is than the reduced down thing. So it will always be a larger number divided by a smaller number because you're looking for the common multiple. Once you've worked out that common multiple, apply the common multiple. Multiply each subscript in the empirical formula by the common multiple in order to get the molecular formula. So as an example for this, and this is a huge type of problem, so you want to put a big star circle next to this, because this question is on the Regents exam every single year, and it will usually sound exactly like this. Determine the molecular formula of a substance that has a molar mass of 84 grams per mole and an empirical formula of CH2. So they've given us the empirical formula. They've told us that the gram formula mass of the molecular formula is 84.0 grams per mole, and we want the molecular formula, right? Determine the molecular formula. So in order to do that, we want to figure out the common multiple. This, right, this is our reduced down version. We know that we're going to be maintaining this 1 to 2 carbon to hydrogen ratio. This is the true, from the true formula, the 84 grams per mole. So the key is we need the gram formula mass of the reduced down version. because that will then help us figure out the common multiple. So I want the gram formula mass of the reduced down thing, which is CH2. So that's going to be a carbon plus 2 hydrogens. So that's going to be 12.0 plus 1 plus 1. And when I do that, I get 14. Right? 14 grams per mole. So this is the gram formula mass of the empirical formula. 14 grams per mole. Okay, I'm going to erase some of this because I need a little bit more space. So we know that the real thing, again, the real thing, true formula, weighs this much, and the reduced down thing weighs this much. So in order to get the common multiple, you're going to divide the gram formula mass of the molecular formula, the true thing, by the gram formula mass of the empirical formula. And this will tell you the multiple. So the gram formula mass of the real thing is 84. The gram formula mass of the reduced down thing is 14. When you divide 84 by 14, you get 6. This means that the real thing is 6 times larger than the reduced thing, the empirical formula. The molecular formula is 6 times bigger than the empirical formula. Well, what's the empirical formula again? The empirical formula in this problem is CH2. The molecular formula will be 6 times bigger than CH2. So how do you make CH2 6 times larger? We're going to take our CH2, we're going to take our subscripts, and we're going to multiply each of them by 6. So the carbon subscript is 1, so 1 times 6 is 6, so C6. The hydrogen subscript is 2, so 2 times 6, that's 12. This is your molecular formula. That's your real thing. That's your not reduced down thing. And you can actually check this, because if you calculate the gram formula mass of this, it should be 84. And if it isn't, then you done made a mistake. You should go back and fix it. But it's nice that there is a built-in check in this type of problem.